Hello, and welcome to Probability Accounting Techniques. My name is Tuesday Johnson. Here's an introduction to concept with applications. Let's start by modeling probability. Now, we know that to model probability of an event E, we use the notation the probability of E is the number in E divided by the number in S. So the number of ways the event E could happen divided by the number of ways the entire sample space can happen. Whenever probability is asked for, your answer is always a proper fraction. So if you're going to write it as a fraction, your numerator is smaller than your denominator. If you're going to write it as a decimal, because decimals are actually fractions, if you're going to write it as a decimal, it's a decimal with no whole number, right? Always less than 1, never negative, so always between 0 and 1. A proper fraction has the numerator smaller than the denominator. And we can see here in this cute little graphic an impossible event, everything from 0 to 1, nothing negative, nothing higher. And you can see where some things land on the scale along there as well. And sometimes when it comes to modeling probability, decision algorithms can be super helpful. That's why we talked about them already. Alright, so let's suppose I gave my finite math class a pretest with 3 parts. They could do part A, or they could do part B and part C. Part A has 14 true-false questions. Part B has 5 matching questions. And part C has 5 multiple-choice questions, each with 3 possibilities. Now I'm looking at this, and part A has 14 questions. Part B and C has 10, right? So I'm thinking maybe parts B and C will be easier. Let's see. What's the probability that you earn 100% by guessing on part A? Well, we know the number of ways to earn 100% is 1. You get every single answer correct. The number of ways to answer a true-false exam, let's see. For question 1, you could answer either true or false. And then, for question 2, you could answer true or false. And then, for question 3, you could answer true or false. Don't worry, I'm not going to do this 14 times. But every question has 2 options, true or false. So we'll have 2 options 14 times, and 2 to the 14th power is 16,384. If we put this together, the probability that we get 100% on part A is 1 out of 16,384. That's why we studied. Just a second. Alright, so let's keep that answer. What's the probability that you earn 100% by guessing on parts B and C? Well, there's only one way to earn 100%. Right? Always. You just get every answer correct. The number of ways to answer part B. Now, part B is matching. Why does that say had? That should have said has. Oh, had. I know why. It's because my grammar's not awesome, and I only changed one slide and not all of them. We'll go with it anyway. Part B is matching. So you read the first question, and you have 5 options to match it with. And then after that one's finished, the next question, there are only 4 options that haven't been used yet, and then 3, and then 2, and then 1. This is matching questions are a straight up permutation. Alright, so that's 120 options just for part B, not bad. The number of ways to answer part C, right, 5 multiple choice questions, each with 3 possibilities. So 3 possibilities, A, B, or C for question 1, A, B, or C for question 2, and so on, 5 times. So we have 3 options for 5 questions, so 3 to the 5th power is 243 possible answers on part C. Let's put this together. Probability of 100% on B and C. 100% has 1 chance, sorry. B and C, so we'll multiply those in our denominator, 120 and 243, so we'll multiply, so we'll get 1 over 29,160. What? Those 10 questions are going to give us a smaller probability than the 14 questions. What? Which is a better choice if you've not studied for the exam? Well, think about it like this. If you're going to win free tuition for life, you could stay in school for the rest of your life and never have to get a job. It's the goal of some of us. Would you rather go to and every school has this drawing, would you rather go to a school where they draw 1 out of a population of 16,000 students, Or would you rather draw 1 out of a population of 29,000 students? We're going to go, since the numerators are the same, we're going with the smaller denominator. We're going to do the 14 true false question. Excellent, excellent. All right, let's make some money, since we didn't win the whole free tuition for life. The table below shows the historical annual data of the Dow Jones Industrial Average, also known as the Dow, from 2015 through July of 2022. If you selected 3 years at random, what's the probability that all 3 years saw a negative annual percentage change? Okay. What do we have here? 1, 2, 3, 4, 5, 6, 7, 8 years. And I see 3 of them that have a negative change. Let's see here. There are 8 years represented. All right, 8 years represented, and we want 3 years. So in general, without any particulars about what's going on, the number in the sample space is the combinations of 8 different years chosen 3 at a time. So there's 56 different groupings of 3 years we can have. We want to know how many of those groupings will have all the negative ones. So the event E saw a negative annual percentage change. The number in E will be, okay, so we're going to separate these. We have 3 of them that are negative, and we want all 3 of them. So the combinations of the 3 negative annual percentage changes, we want all 3 of them. And then, right, we've got to take care of all 8. 3 of them are negative, 5 of them are positive. That's awesome. But we want all 3 negative. We want 0 of them that are positive. Okay, so the red for the red ones listed, the green for the green ones listed. Always the first 2 numbers, 3 and 5, give us the 8 overall. The second numbers, 3 and 0, give us our 3 overall. We've accounted for all of the possible years. And it turns out the combinations of 3 items taken 3 at a time, there's only one way, you take them all. And if you have 5 items and you want none of them, you just walk away. There's one way to do that. So 1 times 1 is 1. And the probability that if we select 3 years at random and we get all 3 negative years, it's less than 2%. So we're actually not that bad. Now if you select 4 of these years at random, what's the probability that you include the pandemic years of 2022, 2021? Wow. And 2020. I went backwards there for some reason. See, I'm telling you, it goes. I don't know. So we start with, we have 8 years. We want 4 of them, right? No, nothing particular, nothing specific, just in general. 70 different ways we could group 4 years at a time. The event is E, includes the years listed. So there are 3 years listed, and we want all 3 of them. And then, out of the 5 years not listed up here, we want 1 of them, right? So we want a group of 4. So we have these 3 years in 2019, or we have these 3 years in 2018, or these 3 years, and so on, right? So there's 5 different choices there, because C of 3, 3 is 1, and C of 5, 1 is 5. Our probability is now a 5 over 70, known as the proper fraction. Always simplify your fractions if you can. It's just a good habit to get into. Or decimal here, 0.0714. All right. What if you selected 4 years at random and you wanted to find the probability of at least one of those selected had an annual change above 20%? Let me see. What do we got? Oh, we don't know. Okay. At least one. Let's just start the problem. If you select 4 years at random, with selecting 4 from 8 gives 9. Selecting 4 from the 8 total gives N of S is C of 8, 4, which is 70. Always check your calculations, by the way. Hit pause. Make sure I'm right. Make sure you can find that. That's the important thing. I can pull numbers out all day long, but if you don't see how I get them, the video's not very helpful. So don't forget, pause is your best friend. At least one. I'm selecting 4. At least one means it could be 1 or 2 or 3 or all 4 of them. Until we look over here and we see that there's only 2 above 20%. So we only have 2 alternatives to consider, not 1 or 2 or 3 or 4. So let's do that. Or at least one will be 1 or 2. Let's use the decision algorithm. Alternative 1, one stock is above 20%. Okay, so we choose one stock of the two that are above 20%. So C of 2, 1 combinations of two stocks above 20%. I want one of them. And then I want 3 stocks, right? Because I want a total of 4 from the remaining. Well, if 2 of them are above 20% and we have 8 total, there must be 6 stocks that are not above 20%. The 2 and the 6 give us a total of 8. The 1 and the 3 give us the total we want of 4. So that's one alternative. Second alternative, both stocks could be above 20%. So we'll choose 2 stocks of 2 above 20%. And then we'll choose 2 stocks out of the remaining 6, right? Because we still need a group of 4. If we write that out in equation form, the number in E will be C of 2, 1 times, right, because of steps, C of 6, 3, plus, moving on to our next alternative, C of 2, 2 times C of 6, 2. And when we work that all out, we'll get 55. So if we want at least one stock above 20% and we're choosing 4 randomly, we have a 78% chance, 78.5% chance of getting at least one of them. So that's good. You know, just randomly grabbing 4. That's a pretty good option for it. Alright, thank you for watching and listening. Be sure to subscribe to Math with Tuesday on YouTube and stay tuned for more videos.